Hello, Miss Teasley here. Today we're going to talk about factoring polynomials. I want to start off by filling in the information at the top. So it says the process of finding polynomials whose product equals a given polynomial is called factoring. A polynomial with variable terms that cannot be written as a product of two polynomials of lesser degree is a prime polynomial. A polynomial is completely factored when it is written as a product of prime polynomials. All right, so factoring, we're going to be undoing multiplication. So when you're undoing the multiplication, you're writing the factors as two prime factors. We're going to start off with factoring out the greatest common factor. So the first time I do it, or the first example, I'm going to kind of do it the long way so you can see exactly what's going on with this greatest common factor. So first of all, let's start off with the numbers. So I have 6a squared minus 18a to the fourth. When I look at the 16 and the 18, when it comes down to greatest common factor, I want to know what's the largest number that I can divide into both 6 and 18. That number would be 6. I can divide 6 into 6, and I can divide 6 into 18. So what I'm going to do is I'm going to use the 6 to rewrite this polynomial. And I'm going to also expand the variables. So this is 6 times 1. And I'm going to write my a times a, minus 6 times 3. Just want to kind of color code it. And then I have 1, 2, 3, 4 of the letter A. So I have the 6, so both terms have a 6. So I'm going to go ahead and highlight that. I have a 6 here. Oops, didn't mean to do that. I have a 6 here, and I have a 6 over here. Then I want to highlight how many A's can I take away from both terms. So the greatest amount of A's that I can get from both would be 2 A's, or a squared. So I can highlight 2 A's over here, and I can highlight 2 A's over there. So the stuff that I have in yellow is the greatest common factor. So from here, my greatest common factor, or GCF for short, is going to be a 6, and then I have 2 A's highlighted. So this would be 6a squared. Then I write a parentheses, because remember, we're just undoing this. This should be a product of two prime factors. What goes in parentheses is what I didn't highlight. So if you notice, in the first term, I have this 1 minus, when I get to the next term, I have a 3, and I have 2 A's left, so that's 3a squared. So this is the factored form of this 6a squared minus 18a to the fourth. So that's one way of doing it. All right, expanding it. All right, so now let's go down the line. So here for part B, 14x to the third y squared, I have this minus 28 x squared y to the third plus 21x squared y squared. So we want to start off with the number. What's the greatest common factor between 14, 28, and 21? And that number would be 7. So you want to leave yourself some space below it. So I'm going to put my 7. Then when it comes down to greatest common factors of the variables, you look and you want to make sure that all the terms have the variable. So they all three have an x. But the smallest exponent of x would be x squared. So we want to take out an x squared. You can't take out more than x squared because the last two terms only have 2 of the variable x. Like if I expanded it like before, that would be x times x. So you only can take out 2 from all 3. So this would be x squared. So when it comes down to variables, your greatest common factor is the variable, and the exponent is the smallest exponent in all the terms. So in this case, it would be y squared. Now I have to figure out, well, what's left, what goes in this parentheses. So let me move this down a little bit. So now what I'm going to do is I'm going to go back to the original problem, and I'm going to divide each term by the greatest common factor, 7x squared y squared. You're undoing multiplication. Well, the opposite of multiplication is division. So I'm going to come back and divide all three terms by 7x squared y squared. So going back to properties of exponents, 14 divided by 7 is 2. You subtract exponents, x to the third over x squared is just x, and the y squareds cancel out. Minus 28 over 7 is 4. The x squareds cancel. Y to the third over y squared is just y to the first power, or y. Plus 21 over 7 is 3, so plus 3. The x squared cancels, and this is supposed to be a squared also. And then the y squared cancels, so I'm just left with a 3. And this is your factor form. Greatest common factor. All right. Same thing for part C. I know it looks a little crazy because you have this x minus 2 in parentheses. All right, but I'm just going to call it yellow stuff. So I have 24 times this yellow stuff to the third power minus 16 times this yellow stuff, which is squared, plus 6 times this yellow stuff. So basically, don't let the x minus 2 throw you off. Just look at it as like that stuff is raised to the third power. Like, look at it as like one variable. So when I go down the line and look at my numbers, I have 24, 16, and a 6. What number can I divide into all three? And that number would be 2. So that would be the greatest common factor. So my greatest common factor is 2. Then when it comes down to this yellow stuff, I have this yellow stuff to the third power raised to the second and to the first power. So remember, when it comes down to variables, so look at this is like the variable, you want to take the smallest exponent. So the smallest exponent between all three will be x minus 2 to the first power. So this is my yellow stuff, which just happens to be x minus 2. And then I'm going to do exactly the same thing as I did before. I want to figure out what's left over. So I come back and divide all three terms by my greatest common factor. This is your greatest common factor, the GCF. So I'm going to divide by 2 times x minus 2 to the first. Same thing, 2x minus 2 to the first power. And then 2 times x minus 2 to the first. 24 over 2 is 12. X to the third, well, x minus 2 to the third over x minus 2 to the first power. Subtract exponents. So you have this x minus 2, but now it's raised to the second power squared. When I get to the middle, minus 16 over 2 is 8. So when I divide the x minus 2 squared over x minus 2 to the first power, I keep the x minus 2, subtract exponents, and there's a 1. Give myself some space. And then 6 over 2 is 3, so plus 3. And the x minus 2, they cancel each other out. That's your factor form. So yes, it looked a little crazy at first, but same rule applies. All right, so now we're going to do something called factoring by grouping. All right, so factoring by grouping is going to require that you know how to factor out the greatest common factor. Factoring by grouping is when you have 4 or more terms. But in this class, we just look at, the 4 terms. So factoring by grouping, you want to do exactly what it says. You want to group the polynomials. So you want to group them in pairs. So for my first example, part A, I'm going to put a parentheses around this r squared s and this 3r squared. Then when I get to the second part, I'm going to put a parentheses around the positive 5s plus 15. Then you have to find the greatest common factor for each parentheses. So the first parentheses has a greatest common factor of just a 1 because there's an imaginary 1 in front of that r. And the greatest common factor between 1 and 3 is just 1. Then when it comes down to the variables, I can take an r squared from both, so r squared. And that will be it. So my first greatest common factor is 1r squared. Then I come back and divide both terms in that parentheses by 1r squared, just like I did before. So it's kind of like you have 2 problems in one. When I divide 1r squared s divided by r squared, I'm just left with s. plus 3r squared divided by 1r squared. The r squareds cancel out. 3 divided by 1 is just 3. Then I come back and do the same thing for the second parentheses. The greatest common factor between 5s and 15 is a 5, a positive 5 to be exact. So I put plus for positive 5, put my parentheses. Then I come back and divide both terms by 5. All right, there's no variable in my greatest common factor because that 15 doesn't have a variable. When I divide this, I'm left with s plus 3. So now, if you notice, both terms have this yellow stuff, which is s plus 3. So that s plus 3 actually becomes your greatest common factor. So it looks like the last example, when I had that stuff in parentheses, that was my greatest common factor, that x minus 2. So what I do is I'm going to write down this s plus 3 one time because that's my greatest common factor. And then you write down what's left over. So what happens if I divide both of those terms by x plus 3? Well, the s plus 3 cancels out. And what I'm left with is the 1r squared and the positive 15. So this is 1r squared plus 15. So the first parentheses is the yellow stuff. The second parentheses is the 1r squared and the 5. So like that's the GCF from before, the previous step. It doesn't matter which order you put your parentheses in, but I normally just put that yellow stuff in parentheses first. Like whatever that is, I normally put that out first because that's your greatest common factor. That's technically what you're dealing with. All right, so I know I went through a lot. We did factoring out the greatest common factor. I just explained a factoring by grouping problem, which requires factoring out the greatest common factor. So I want you to pause the video and try examples B and C. All right, try both, B and C. All right, so I hope you had a chance to try part B and C. So I'm going to go through the same process again. I want to factor out the greatest common factor, but I need to group them in pairs first. So in the first parentheses, the greatest common factor, I don't have anything other than a 1 that I can factor out here. So this would be 1. And if I divide both of these by 1, you're just going to get what's in parentheses, which is 4m squared minus n squared. When I get to the next parentheses, the only thing I can factor out is a 1 and an n. They both have an n in common, so plus n. Let me put that in purple. And when I divide both of these by n, I'm left with a 4 minus m squared. Let me see if I should have got m squared. M squared. All right, here they don't have anything in common, so I can't factor anything more. Let me try rearranging this. All right, because they don't have anything in common. So if I rearrange this, let's see if I put the 4m squared minus n squared, and then put the, well, actually, let me bring this mn squared. So let's see. All right, so let's see what happens if we rearrange it and see if we can factor. All right, looks like it's going to be the same. So if I factor out an m squared, I'm left with just 4 minus n. And then here, if I factor out an n, I'm left with n minus 4. All right, so this problem right here requires us to do some rearranging. So let me back it up. All right, and I hate that you had to do that on your own, so let's back this up. I'm going to erase and I'm going to start over. So if you kind of got stuck on that, hopefully it didn't discourage you, and hopefully it didn't discourage you from trying part C. So a problem like this, so if you notice, I tried to factor it and I didn't see a greatest common factor. So what I'm going to do now is I'm going to rearrange the problem. I'm just going to flip-flop the two terms in the middle and write this as 4m squared and then plus 4n minus n squared minus m squared n. Let's see, n minus m. All right, so now let's see what happens. So I'm going to try to factor by grouping. I'm trying to work ahead. In the first parentheses, the greatest common factor would be 4. And when I factor out of 4, I'm left with m squared plus n. Now, when you get to the second parentheses, because your first term is negative, you want to factor out a negative. So whatever your GCF is, you want it to be, you want to factor out the negative with it. Let me see if I can move this down. Let's see. So I'm going to need some space. So I'm going to factor out a negative. And the greatest common factor between the terms here would just be a negative n. All right, let me show my steps in between. So the first one, I divided both of these by 4. And over here, I'm going to divide by negative n, because the greatest common factor is negative. So negative n squared divided by negative n is a positive n. And then the two negatives here become a positive. And mn squared over n, these n's cancel out and I get m squared. So now notice how they both have the same thing in parentheses. Now I can rewrite it. This is m squared plus n minus n. And this would be the same thing as m squared plus n. And so now when I rewrite this, the yellow stuff that I'm highlighting is my greatest common factor. So I write that first. So this is m squared plus n, which is the yellow stuff. And then what's on the outside of your parentheses, the 4 and the minus n, it goes in its own parentheses. So 4 minus n. All right. So I don't think you're going to run into any problems like that. You may run into problems like this on homework, not on a test, where you may have to do some rearranging, but likely not. All right, part C. All right, let's see how we do on part C. So on part C, I'm going to see if I can factor out the greatest common factor from the first two terms. So as you can see, sometimes you may have to do some rearranging. All right, but hopefully this one works out a little smoother. So here, first parentheses, my greatest common factor will be a 3. And when it comes down to variables, it'll be y squared. Then if I come back and divide both of these by 3y squared, 9y cubed over 3y squared is just a 3y. Minus 15y squared over 3y squared is just 5. In my second parentheses, my greatest common factor would be a positive 2. So I divide both terms by 2. 6y divided by 2 is 3y minus 5. So my greatest common factor, what I'm going to write down first, is what's in yellow. Notice when I write the yellow stuff, I write that down one time. So it's 3y minus 5. And if you want to actually see the work, if I come back and divide both of these by 3y minus 5. So just like before, 3y minus 5 cancels out. And what you have left is 3y squared plus 2. So again, what's on the outside of the parentheses goes in a separate parenthesis. So 3y squared plus 2. All right, so that's factoring greatest common factor. All right, so here we have what you're going to see a lot, or mostly, will be factoring trinomials. So again, factoring is the opposite of multiplication. You're undoing the multiplication. The first part, we're going to look at factoring trinomials. All right. So I'm going to use a method called slide and divide. So let's see. All right, before I get to slide and divide, let's do some. They don't have any simple examples up here. Slide and divide. Let's look at some simple examples first before we start jumping into the slide and divide stuff. So I'm going to make up some examples here. So let's look at some really simple ones. So here you have x squared minus 5x plus 6. when you factor in this form, your goal is you're going to have these two parentheses. So this is for trinomials. You have two parentheses. What's in your parentheses first, what's in both parentheses should multiply and give you x squared. Well, the only way you can get x squared is just x times x. Then the next number in your parentheses, or the next term in the parentheses, should multiply and give you the 6. So it's always what multiplies to give you the first term and the last term. So I'm trying to find out how to multiply, what two numbers multiply and give me 6. Well, there's several ways to get 6. First of all, in order for you to get a positive, you're going to either multiply two negative numbers or two positive numbers. All right, they have to have the same signs. That's the only way you can get a 6. Then I can get a 6 by multiplying 1 times 6, 2 times 3. So I have two options here. I can use 1 and 6, 2 and 3. I will have to use both signs, the same sign for both numbers. So this is when the middle number comes into play. This is the only time you use this negative 5x. The negative 5x determines which pair I'm going to choose. I need to choose the pair of numbers with the same signs that's going to add and give me a negative 5. Well, if I'm trying to add and get a negative 5, that means clearly I'm going to be using a negative times a negative, or negative and negative. So what two numbers over here between 1 and 6 and 2 and 3, if I make them both negative and add them together, would give me a negative 5. And that answer would be negative 2 and negative 3. So that's how you factor. All right, let's look at another one. Example, let's see. I'm trying to make up something off the top of my head. Let's see, x squared. Let me see. Minus 8 plus 6x. Actually, all right, let's make this. All right, that was that. This should work. Actually, it should be 7. All right, bear with me. I'm trying to just make up some simple problems so you can see the simple ones first. So now I'm going to try to find factors of x squared plus 7x minus 8. So I'm going to have two parentheses. Remember, it has to multiply and give you x squared. The only way you can get an x squared is x times x. So that's normally the easy part. Then I want to find the two numbers that multiply and give me a negative 8. Well, first of all, if it's negative, I have to have opposite signs. The only way you can multiply and get a negative is a positive number times a negative number. So my factors of 8 would be 1 times 8, 2 times 4. So I'm looking for the pair. So again, this is when that middle number comes into play. So I'm looking for the pair that when I add them together, and remember they have to have opposite signs. When I add them together, it's going to give me a 7. So basically, you're pretty much subtracting. What two numbers, if I subtract them, can give me a 7, and that would be the 8 and the 1. The 7 is positive, so you want your bigger number to be positive. So you'll want this to be the positive number, the 8 to be positive, and the 1 to be negative. So negative 1, positive 8. When you check it, negative 1 times a positive 8 is negative 8. And negative 1 plus 8 gives you the positive 7. So we're going to be using this to help us with the other types of problems. If you notice, the two that I just did, the first term was x squared. The only way you can get an x squared is just x times x. But what if you have a number in front of your x squared, or like in the first example, they're using a z squared. So I use this method called slide and divide. So if you look it up, you might see this, on YouTube somewhere called slide and divide. So to factor this trinomial, first thing you want to do, any type of factoring problem, you want to check and make sure there's no greatest common factor. All right, so I look at all three terms. There's nothing I can take out of all three terms, so there's no greatest common factor. So then I dive into this slide and divide stuff. So the issue is there's a number in front of my z squared. So I can't go and use the shortcut I did up here with the last two examples. So what I'm going to do is I'm going to move this 5 out of the way. So this 5 is basically in the way right now. So what I do is you have the ability to take this first number, which is 5, and you're literally going to slide it across the page down here beside the 12. So there's your 5. And you're multiplying it. So if I move the 5 down to the other side, I have z squared plus 4z minus 12 times 5 is 60. So now when you look here, you have something similar to what we did before. All right, I have a z squared. I can factor this. The way that I factor this is the only way you can get a z squared is z times z. So you go down and do your factoring like you did before. Z times z. Then I need to find two numbers that multiply and give me a negative 60. Well, the only way you can get a negative, first of all, is you're going to have opposite signs. So I have the 60. The signs are going to have to be negative. This is negative 60. The signs are going to have to be opposite. So whatever two numbers I choose, the signs have to be opposite numbers. So let's kind of go down a line. So 1 times 60, 2 times 30, 3 times 20. Let's see, 4 times 15, 6 times 10. And so let me just look here and see, hopefully with the numbers I have listed here, I can find a pair that when I add them together will give me a positive 4. So remember, they have to have opposite signs. So when you're dealing with opposite signs, that means you want to subtract the number. So which pair of numbers, if I subtract them, take the difference, will give me a 4. All right. And so if I look here, the 6 and 10 will work. Since your middle number is a positive 4, you want the 10 to be positive and the 6 to be negative, because when you add them together, you should get a positive 4. So this is negative. All right. But you're not done, because now remember to check your answer. First of all, when it comes down to checking your answers, the first two terms should multiply and give you 5z squared, and the other two terms in the parentheses should multiply and give you negative 12. So clearly we're not done, because z times z is z squared, and then we have this plus 6 times negative 6, which is negative 60. So think about what this is called. This is called slide and divide. So I did the sliding, which really is like multiplying. And now to undo what you did in the beginning, since you multiplied by 5, you have to undo it by dividing by 5. So in the beginning, I multiplied by 5, and that was just to help me factor. So now I have to undo what I did, which is multiply. So I'm going to divide both numbers by 5. So go into parentheses, and both numbers, you're going to divide it by 5, because you're undoing. So whatever you multiply by in the beginning, you come back and divide by that same number. So now I have z plus 10 over 5 is 2. And then in this next parentheses, I can't do anything with 6 over 5. 6 over 5 can't be reduced. You don't leave it as a fraction. What you have to do is, remember, you have the ability to move numbers. So what you're going to do is you're going to take the 5 that's in the denominator, and you're going to bump it and put it right in that same parentheses, but you move it and put it in front of the z. So this becomes 5z minus 6. And now let's check. Let's check to make sure this answer is correct. So to check it, to do like a little soft check, let's see if I can use this green. If I do z times 5z, I get 5z squared from the original problem. So far, so good. Then if I do positive 2 times negative 6, there's my negative 12. So safe to say this is the correct answer. All right, take some work and practice. All right, let's look at part B. Part B, same thing. I look here, I have a number in front of my t squared, so I'm going to use this slide and divide. I take this 12 and I slide it across the page. So now this is t squared minus 5t. Remember, the 12 comes down here. Minus 3 times 12 is 36. So now I want to go through that same process. T times t. I'm looking for factors of negative 36. First of all, the only way you can multiply and get a negative is if you have opposite signs. So I'll go ahead and make a note. I need opposite signs, positive and a negative number. The factors of 36 will be 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And so now, And before I forget, let me show you a shortcut on how to find factors. So because sometimes you might get some really big numbers and you might want a nice little chart on the factors of a number. So what you can do is I'm going to go to my calculator so I can pull up my old calculator. All right, I haven't used this in a while. You go to y equals. You definitely don't need all that stuff. And whatever number you're trying to find a factor of, you need to divide it by x. So I'm trying to find a factor of 36. Don't put a negative, just put 36 divided by x. All right, save it. And I should better go to a table. All right, so when you go to the table of values, if you start with 1, the factors of 36 is 1 times 36. It goes side by side. 2 times 18, 3 times 12, 4 times 9. When I get to 5, 5 is not a factor because the other number is a decimal, 7.2. So the next factor will be 6 times 6. So this is just a helpful way. You skip 7 and 8 because they're not factors. The next one will be 9 times 4. All right, and so forth. So that's how you can find your factors. So whenever you have a big number or you can't memorize or remember factors, just pull it up and use your graph. All right, so now back at it. Opposite signs you're going to have to subtract. So which pair of numbers, if I subtract them, can give me that -5? So clearly this 4 and 9 will work. Since the 5 is negative, that means that I want the bigger number to be negative. So -9 and +4. It does not matter which order you put, which parentheses you put the numbers in. Now remember, you came and multiplied by 12. So now you have to undo it by dividing both numbers in parentheses by 12. Before you do anything, you want to make sure you simplify or reduce fractions before you do any type of bumping to the front. So I see a 9 over 12. I'm not going to just move that 12 to the front first. I'm going to see if I can simplify 9 over 12. So I asked myself, what number can I divide into both 9 and 12? And that would be 3. 3 goes into 9 3 times, and 3 goes into 12 4 times. Then when I get to the next parentheses, I have t plus. What number could I divide into both 4 and 12? And that will be 4. 4 goes into 4 once. 4 goes into 12 3 times. And now that my fractions are reduced and I still have fractions left over, any denominators you want to bump and put right in front of that same parentheses in front of the variable. So whatever parentheses you're in, that denominator comes in front of the variable. So this would be 4t minus 3 and then 3t plus 1. And if you want to check it, remember it should multiply and give you the original. 4t times 3t gives me 12t squared. So far so good. And -3 times +1 gives me the -3. So again, it's safe to say that these answers are correct. All right, go ahead, pause the video and see if you can try letter C and D. All right, so hopefully you had a chance to pause the video. All right, I'm going to work out C and D. So for part C, I'm going to try my slide and divide. So 3, slide it on down here, times 3. So this is x squared minus 15x plus 48. When I factor this, x squared breaks down into x times x. 48. In order for me to get a multiply and get a 48, I have to have 2 positive numbers or 2 negative numbers. The factors of 48, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So since they have the same signs, I need to add them together to get a 15. So if I look over here, I don't see a pair that I can add together and get a 15. So that means that this polynomial is what we call as prime. A prime polynomial is a polynomial that can't be written as 2 prime factors, as I said in the beginning when we did that fill in the blank. So this is prime. So whenever you get to a number or a polynomial that can't be factored, you just choose the option or write down that it's prime. All right, again, hopefully that didn't throw you off and discourage you for trying part D. So let's jump in and try part D. So I'll do the same thing. I'm going to do my slide and divide. So this is x squared plus 42x. Move this 24 down here. This is going to be a big number. So 15 times 24. So let's see. 15 times 24 is 360. So since it's a positive 360, I need the same signs. They either have to be two positive numbers or two negative numbers, and I'll be adding them together. So since 360 is a really big number, I'm trying to add and get 42. I'm going to use my table. This would be the perfect example to use the table. So 360. So I go to my table, go to y equals, and make this 360 divided by x. And go to my table. So let me see what we're trying to find again. We're trying to find two numbers that add and give us 42. So going across, so let's see, 42. All right, here I see 30 times 12, or I guess I could have quoted up here 12 times 30. All right, 12 times 30, and when you add 12 and 30, you get 42. So again, that table is really helpful. So x plus 12, because you're trying to get a positive 42, and x plus 30. Now I need to come back and divide both numbers by 24. Remember to reduce your fractions first. So reduce, reduce, reduce. When I reduce the fraction, the number that can go into both 12 and 24 would be 6. 6 goes into 12 twice, and it goes into 24 4 times. Well, actually, I need to do something bigger than that. Let's see. 12. 12 goes into 12 once, and 12 goes into 24 twice. So 1/2. And then here, 30 over 24, the number that can divide into both. Let's see, we can do 6. So 6 goes in 35 times, and 6 goes into 24 4 times. And now I bump the number in front of the x. So this is 2x plus 1. And then this is 4x plus 5. All right, something didn't work out right. Let me see. What did I do wrong? What did I do wrong? All right. 12 times 30. 24. Oh, I know exactly what we did wrong. Or what I did wrong. Hold on one second. All right, this is a prime example. All right, so this is correct, but if you notice, I don't get the same thing. 2 times 4 is 8x squared, and then 5 times 1 is 5. The reason why is because I mentioned it early, but the first rule of factoring is you always take out a greatest common factor. So when you look at this problem, go back to the original problem. The greatest common factor between 24x squared, 42x, and 15 would be a 3. I'm going to put it over here. So if I divide all three terms by 3, 3 goes into 24 8 times. So this is 8x squared. Then you have 42 divided by 3, which is 14. And then 15 divided by 3 is 5. So if you factor what's in this parentheses, all right, you should get 2x times 4x, which is 8x squared. And then the 1 times 5 is 5. So what I'm missing is my greatest common factor. So what I should have did originally, and this is good stuff because you don't want to make the same mistake I did. I'm trying to get rid of this. Okay, good. So what I should have did first was I should have scanned the problem and factored out any greatest common factor, which in this case there was a 3. And what's left over, this is the process that you go through. All right, and notice at the end. So if you notice, if you don't factor out the greatest common factor, your final answer is not going to be correct. What's in parentheses is correct, but if I multiply that 2x plus 1 times 4x plus 5, I'm only going to get 8x squared plus 14x plus 5. I will need to have that 3 in the front. So again, always start off by scanning the problem and checking for a greatest common factor first. All right, this next part says factoring perfect square trinomials. All right, the way that this factors, x squared plus 2xy plus y squared would be x plus y quantity squared. And then this is x minus y quantity squared. So the way that this works, so you still can use the slide and divide method, but sometimes you might see a polynomial and you might recognize, oh, this is a perfect square trinomial. It's a perfect trinomial. Perfect trinomials means it factors like the x plus y squared or x minus y squared. All right, this is the same thing as just x plus y times x plus y. Or this is x minus y times x minus y. But the way that we want to write it, you don't want to write the same parentheses twice, so we put it as a square. So first thing is, how do I know it's a perfect square trinomial? Well, the first thing you want to do is you want to kind of check and see. So if you look at both terms on the end, 49x squared and 4y squared, they look like perfect squares. And when I say perfect square, if I take the square root of 49x squared, I get a 7x. And if I take the square root of 4y squared, I get 2y. So they're perfect. The two end terms are perfect. I can take the square root of them and I get something. I get 7x and I get a 2y. To figure out the final answer, you want to check. So if I look at this formula, if it's a perfect square trinomial, that means that when you multiply what you have down here, the x and the y, which in this case would be 7x and 2y, if you multiply these together, and you have to multiply it by 2. So 7x times 2y, when you do 7x times 2y, you get 14xy. And notice in the formula they have that 2 there. So I have to multiply that times 2. So 2 times 14xy equals 28xy. So you have to go through this extra step to make sure that that middle number is the same thing, 28xy. So since I know that when I multiply the two end numbers after taking the square root and multiplying it by 2, I get that middle term. That means that this is going to factor as 7x plus 2y quantity squared. All right, because whatever you have here in front of your middle term is what goes in the middle. All right, I know that was a mouthful, but that's how it works. All right, so let's try here. The next one, the square root of 81a squared b squared. So when I take the square root of this, I get 9ab. And then I take the square root of 25, I get 5. So let's just assume, so if they tell you that it's a perfect square trinomial, then you should know that this will work out. But let's just see. If I do 9ab times 5, I get 45ab. And if I multiply that times 2, I get 90ab. So that means that this is not a perfect square trinomial. This actually is not going to be factorable. This is going to be prime. All right. So let's see, 9, 5, 5. Yep. All right. So, and really honestly, sometimes I'll look at polynomials and I may not even recognize it as a perfect square trinomial. If you do the slide and divide stuff, it's going to work itself out in the end. So let's just say if I was to factor something like, if I had x squared plus 4x plus 4. If I factor this ends up being x plus 2 times x plus 2. All right, so I will go through the same steps, x plus 2 times x plus 2. Oh, well, I have two x plus 2s, so I can write this as x plus 2 squared. So you don't have to go through all that stuff with the formula and identifying this is a perfect square trinomial, but I know that at the end because when I factored it, I had the same parentheses twice. So Again, I don't want that perfect square trinomial stuff to confuse you, but they do want to expose you to it. All right, the last part would be the binomials difference of squares. So difference of squares, x squared minus y squared would be x minus y times x plus y. This is how this factors. And then the sum and difference of cubes, we'll actually get to that, but I'm going to give you the formula. It's x minus y. We'll get to that in the next video. Times x squared plus xy plus y squared. And then the sum of cubes is x plus y times x squared minus xy plus y squared. There is no factoring pattern for a sum of squares. There's a factoring for difference of squares, but not sum of squares. So we're going to do example 5, and I'll pick up example 6 in the next video. So factoring difference of squares. I see two terms. I want to make sure that they're perfect. So when I take the square root of 64r squared, I get 8r. And then when I take the square root of 49, I get 7. So the way that this factors, because I have two perfect squares and I'm taking the difference between the two, is you take the 8r plus 7, and then you put another parentheses with 8r minus 7. That's just how it factors, without having to go through like any type of slide and divide. Same thing for part B. I want to look and I see a minus sign. I see two terms. So this may be a difference of squares. So I'm going to take the square root. And again, this will be a good example where you can actually pause the video, stop and try it. So try to do this difference of square problem. All right. So now going back here, let's take the square root of both terms. 169u to the 6. When I take the square root of 169u to the 6, I get 13u to the 3rd. And then when I take the square root of 144v to the 4th, I get 12v squared. So since they're both perfect, the way that it factors is 13u cubed plus 12v squared, and then 13u cubed minus 12v squared. Oops. Let me see if I can move this over because that's ugly. All right, guys, and that's it for this video.